Good evening, friends. Welcome to Eason Academy, and we are into embedded system programming. And today we're going to start a new session called embedded systems. So this is what we're going to do. That it's a very critical. And you know that embedded systems programming. So on that, what is embedded systems? That's what we're going to discuss today. And today's is session 1. And we will give a small introduction about embedded systems. That's a very important. So we try to do a lot of things without understanding what is embedded systems. We have a lot of confusion on that. So let us start from scratch. So always have a good idea about where we are going to go. That will give you a right direction. So that's very important. So first you need to fix a direction. Then on that direction you have to travel slowly. That's what the life. That is what your money and your time, effort, everything. You cannot waste your energy in all the directions. That's not possible because you have only limited period of life. You have only 24 hours a day. And after your sleeping hours and other hours, everything, you will be very, very minimal time. The world have thousands and thousands of things. You cannot become master of everything. So fortunately, you have selected a field which is having a huge demand in the market. That's a very, very important to know. To understand. So the trick here is, before we get into what is embedded systems, we have to discuss something extra. That we will do it right now. So that is the trick here. The trick here is almost zero confusion. We should know about what is electronics. What is electronics? That's a trick. In electronics, is nothing but you give an input of electrical signal and you get the output of electrical signal. That's all. This you have to understand. If you want to understand about embedded system, you should know about electronics first. Why? Because embedded system is a branch of electronics. So what is electronics? It takes electrical signal input and electrical signal output. It does the processing. For that, they start using a lot of components in time. The most important component is a transistor. We discussed very thoroughly about transistors in our electronic session, not in here. Here we are going to discuss about embedded systems. So what is transistor does? So the top level, it's quite simple. A transistor is a variable resistor. It can vary from 0 ohm to infinity ohm. 0 ohm means short. Infinity ohm means open. That's all. And in between, you have a various ranges. 0 ohm to infinity ohm. Understand? Basing these properties. And this, the only trick here is, in your college or not, variable resistor means you control manually. Here you are controlling through the input voltage. That's why even the founders, the inventors of this transistor have mentioned in that nobelprize.org site why they are given a name called transistor. It's called transfer resistor. But what is transferring? It is transferring a voltage into resistor. It is converting a voltage into resistor. Every corresponding voltage, there is a value of resistance. That's it. Using that, what we do here is internally, we connect the resistors, transistors. The output is input. Something, forget about the circuit, what it does. I'm not worried about that. So this is what generally your concept from the school days you have been taught. The moment if I ask anybody, you go and ask electronics, they will tell you it is a circuit or components. So whenever you ask anybody about what is electronics, you have a problem. So electronics is nothing about physical components. It is about the relation between input and output, that you can call it as a X, Y, F of X. That's it. What you do here based on the circuit, what you draw here. And based on the usage of the transistor, are you going to use the transistor as a variable resistor or a switch? Okay, you can use one of them. We call this as analog and digital. So let us forget about this temporarily analog electronics. We move into the digital electronics. In digital electronics, we have switches, full of switches only. There's nothing. The moment you say digital, that means that the transistor, I'm using the transistor as a switch. That's it. Nothing more than that. That means internally full of switches. How do I connect them? How do I do that? For that, what people did was, they have done a wonderful thing. They created few logic gates. Like we have addition, subtraction, multiplication, and division in mathematics. In this digital logic, they created three logics: and, or, not. We're going to discuss about thoroughly on our digital electronic sessions. But right now we understand about this. So what we do here is this: if you give both the inputs are 5 volt, output is 5 volt, otherwise 0 volt. If one of the input is 5 volt, the output is 5 volt. 5 volt means 0 volt, 0 volt means 5 volt. That's it. Very simple. See, the digital electronics is doing a miracle. We know that. Today it's going everywhere. Digital economy, you do everything. All the artificial intelligence, all the machine learning, everything is possible because of the wonderful, these 3 gates. That's a trick. You may not know that. These 3 are the one which are doing the wonderful things in the world. And they are very simple. They are very simple, not any complicated. Even a child can do. Hey, both of them are 5 volt, output is 5 volt. One of them is 5 volt, output is 5 volt. If 5 means 0, 0 means 5. That's all. You have to remember only this. You will do wonders. Now what people did was, they had used the gates internally. They used the gates internally and built the circuits. Whatever you saw, whatever it is. Whatever gates, I'm just giving it only logic. Basically, I'm having a multiple inputs. I connect them. I do something. Maybe I may connect an inverter here. So I use all the gates. So this is what we think Am I right? How do you build the gate? It is nothing but few transistor switches. I connect them in series. No, don't worry. Just I'm giving you an idea only. We are going to discuss about this, how they are getting AND gate, NAND gate, and or NOT gate in our digital electronic sessions. Now this is what inside. So inside is this, inside the AND gate is nothing but few gates are connect series. So we know that in electrical, if you connect the two resistors in series, we call series circuit. In electronics, we call that as AND. So what is happening was this gates and the connections gives you some input. You have three inputs, A, B, C, and they have output called Y. That means that you get about ABC. This is digital, can be only 0 volt or 5 volt. You get 2 power 3, 8 combinations. So various inputs. That is what we're going to discuss about in electronics. That's a trick, how we are going to connect with the real world. That we will see end of today. We'll see that real world scenario. Then you will know that what has changed in our days and today. That's a trick. Today, anybody, even a 7th standard students, can do an electronics product at home in a day. The moment you don't know anything about electronics, you start today morning, by today evening, you can make a good product. That's as easy as that. Understand now? So, this is what happening. So what these switches are nothing but, when I say switches, they are nothing but transistors. They are nothing but transistors. And the market transistors are manufactured by 3 leg pins using a silicon. Okay. Or you will see that like this. One is called collector, base, emitter. Collector, base, emitter. There are 3 pins. See, don't worry about this. This is nothing but, let us say we have a switch at home. I connect a battery. Then I put a switch. I put a bulb. And this is having how many points? Normally you say 2. One is here, where you give 5 volt. That's a point A. And point B, you connect to the bulb. You think only 2. There are 3 are there. The third one is this. You use your hand. You use your hand to on and off. So there are 3 inputs are there. 1, 2, and 3. You may call A, B, and 3. A, B, and H, hand. That's why they call this as a manual switch. We call that as a manual switch. But what is this transistor? Same as this, same as switch. Okay. Collector, emitter. But the only trick here is the base. Understand now? So there's literally no difference between the normal switch and this switch. So we are using transistor as a switch in digital electronics, and using the transistor switch, we build the gates. We are easy to operate. It's not so not difficult to operate with the gates. So what we have done was, in those days, when I was in school, I'm talking about in 1970s, we take a small dotted board. We make a small dotted board. And the board, we put the transistor here, and the pins will go down. We put another like that, multiple transistors. and we connect them in such a way that it will do the AND function. That is, I connect the switches in series. I will do the same thing another board, which will perform like a OR. Then I took another board with the transistors, which will perform like a NOT. So, which is the moment you give an input, it gets output. Wrongly. Forget about this circuit. That we will discuss about digital electronics deep. Don't get worried now. Try to understand the block level. So how we did in 1970s was we take a board. Here we have a small connectors. Here we have a small connectors. Like that, we will have a built-in lot of things. Like this, we will have about 5-6 AND boards and 4-5 OR boards like this. So we built all these things, keep it with us. And whenever we wanted to connect, let us say I want to draw a circuit like this. And or not. Assuming I want to draw a circuit like this. That means that if we give 1, 1, the output is 1. 1, 0, the output is 1. Then 0. 1, 1, 1, 0, 1. Okay, because it's a inverted as the inversion. We are not going to discuss about the functionality now. I'm explaining a totally different concept today. Our understanding is what is embedded system. So what we did was we take this board and did it. And before that, to make sure that this is working fine, we used to do it on the breadboard. On a breadboard, we put the transistors and we do all the connections, these connections. The problem with the breadboard is, since every time you press it on the hole and everything, the connection may not be stable. Also, when you try to move, shake, then the connection may go bad. And most of the time when you give a demo, when you try to give a demo, you will know that anybody who would have done the breadboard in the college, you'll be surprised. You will do all the thing, everything will be working for you. The moment you give a thing to demo to your guide, that time this will not work. Am I right? You try to change the wires and make things work. You see, please understand, this is the concept. The concept is electronics is electronics. For the moment they say electronics, it is all about circuits. It's all about circuits. And why we need circuits? Because electronics is an input and output, relation between input and output. Y is equal to f of x. Now, the circuit inside the box decides what input, what output you should give it. That's the thing. That is what we call circuit. That is what engineers are doing it. When I draw the circuits on paper, Then what I do here is, from paper, I migrate it to where? To the breadboard. Because paper is no use. But once I do it on breadboard, why I do breadboard? Because I don't know soldering. And I want to do some component testing faster. Here I just press the things. I do not have to do soldering and removing everything. And also I am testing. So some connections I have to do changes quite frequently. So for all the reasons, because of so many reasons, I start using a breadboard. But after everything is done, I found a thing breadboard. Hey, I tested okay. But when I give a demo to somebody, or when I take it out somewhere, it became too laborious because some connections goes bad. You don't know which one is gone or which one is perfect and everything. Because of that, my demo did not go well. So what I did was, I have whatever circuit working in a breadboard, I transferred to the dotted board. I do a soldering. Then I put a wire, I connect the wires and put a resistor and connect the wires and do the thing. You understand? This is what you do. But here the advantage is I do soldering. Because of we do soldering here, this is so rigid. You can give demo to people. That's what we did. In the school days, we used to build like this. Then one guy told, that time the magazines everywhere, they said, Balaji, you make like this 10-20 boards and or not gates, 10-20 boards. And every board you have to put so many wires and everything. What do you do? Go to the other one. Then I asked, what is that? He said, hey, go for PCB, printed circuit board. This is called dot board. I asked, what is this dot board and printed circuit board? Then we realized one nice thing. We take a sheet where one side is full of copper. One side is full of copper. Okay. The other side, top side, nothing. It's a normal board, Hilum board. They call it as a Hilum. It's a material they use. So the copper is there. What we do here is, whichever pin we want to connect, let us say we want to connect this resistor, this pin to this pin, we draw a thick wire with a pen, black one. Then we do another thick black pen, another transistor. So wherever I want to have a wire and this input, I connect a thick wire, another transistor, connect. These two you connect like this. This you connect to the ground pin. So what we are doing is, we will let me try to show you this in later days, one of the demo, how it's working. Then you will know that. These all software packages are available today. So you know we call them as layout, PCB layout. So what we did was, we connect all of them like this. Wherever we have a thick thing, fine. Then we apply a material and expose it to a chemical. We apply a chemical. Then we expose it on a light for some time. Then after some time, we remove this board and put it on another liquid called developer or ferric chloride. What will happen there? The ferric chloride, when you dip this one, wherever the light not exposed, that copper will be there. Wherever exposed, all the copper will go off. So the board become like this. All the copper will go. But all my connections, what I have drawn, will be there. Now, I plug the component inside and solder it. I need not have to connect the wires. That is the advantage of PCB. In a dotted board, I have a component and wire. In the breadboard, easy to try. Easy to try anything, because no soldering, nothing is required. In this dot board, I have a component and wire and soldered, fixed one. So it's good for demo. The PCB, I need to solder only components. And the connections are already there. So too famous. So there are three things. Understand one thing. The first one is I do it on a breadboard. The second one I do on a dotted board. And third one I do it on a PCB. And they were very happy. And all the boards we do circuits drawing, we put it on a PCB and start doing it. But very unfortunately, when we start drawing a circuits bigger and bigger, then we have to put more. PCB size become big. And number of components become more. I need to solder so many components. It takes very long time. That time only, there is a great engineer called Jack Kilby. Jack Kilby. He was working in Texas Instruments, US. He found a mechanism. Instead of putting the circuit in copper, he put the circuit inside a silicon. You understand? So instead of I buy a separate transistors, transistor 1, transistor 2, transistor 3, everything, and I put it them and then I solder them. Am I right? I solder them. Instead of that, what Jack Kilby did was he put the entire circuit inside the silicon and gave the pins outside. This is called, he called as IC, integrated circuit. That means that I put the entire circuit inside the silicon. Now you understand the 4 types of. So I draw a circuit. Understand one thing. Electronics means circuit. 1. Electronics. Electronics means circuits. That's correct. And then circuits. But there are 4 methods of implementation. What are the 4 methods? One is breadboard. First one, breadboard. Second one, dot board. Third one, PCB. And fourth one, IC. Understand now? These are only 4. These are all called implementation, assuming that you draw the circuit. What they have done was they divided to 2 categories. One is called inside silicon. Or other one is using individual transistors. Either one you can use it. This method is called discrete electronic circuits implementation. So this one is called discrete and this one is called integrated circuit. So what Jack Kilby did was, Jack Kilby put 2 transistors in IC. How many transistors? He put 2 transistors. That seems to be a very great thing that those days. Then slowly they increased to 10 transistors per IC. Even people that time said, okay, fine, man. If what is the problem with this in the IC is, you have a silicon, you put the circuit here, you have a pin. If something is, one transistor goes bad, then I have to throw the entire IC. Think. But here, the discrete, I have a board with so many transistors. If one transistor goes bad, that is not going to affect me. That is not going to affect me. I'll be able to use the remove this transistor and put another transistor, new one. So this is easy to service. This is difficult to service. Almost impossible. But of course, there are some methods we use the laser technology to try to connect the connections during development stage. We do that. They call laser surgery. It's possible here in ICs. So now, if you have understood up to this point, then we can go to the next level. Okay, this point is very critical for us. Now, what they have done was slowly they have started increasing this count. They put 100 transistors per IC. New methodology. They've increased the technology. Then I thought, hey, I take a board, I have to solder 100 transistors. Each transistor is having 3 pins, 300 pins. Apart from that, you have a resistor. To solder all of them, it takes very long time. Also, if you put 100 transistors, the board size is so big. But whereas these people put that into a single silicon, small piece, and make the IC as a small. So space is size. Size is big. That's a PCB or discrete. So there are two methods. I draw the circuit and use it on the PCB, or I put it in IC. Very unfortunately, a lot of people start moving to this. They start using IC instead of PCB. Okay, instead of transistor alone. So maybe a very small percent of people are doing that. Then what they have done, 1,000 transistors per IC. Think of it. That's all. They thought, hey, how do I solder 1,000 transistors, man? So they've totally ditched. So discrete is gone. Discrete is gone. Everybody moved to IC. Now no more discrete. People decided no more discrete. We will do only integrated circuits. So yeah, we will discuss. I wonder how RAM, ROM, controller, everything is embedded inside the silicon. That we will discuss. Yeah, that's why I'm here. That's why you are here and I'm here. Okay. Now what happened? Now what happened? There is a IC. There is a silicon. In that, they print your circuit. And they have a connection. You understand now? But you know one problem here. You know the major problem here. What is the problem? What's the problem with the IC? Major problem. Even though you have 1,000 transistors, if one transistor goes bad, then you have to throw the entire IC. You cannot repair it. You cannot service it. Please. That's a problem here. Also, this manufacturing process is too big. People take a sand, then they build it. Because of that, it takes very long time. The company will not make one piece. They will ask you minimum of 100,000 or 1 lakh pieces, 10,000 or 1 lakh pieces. They will never make one piece. You have to order big. So that's a problem. People thought, how do I change that? That's a beauty. What they have done. That's a beauty. What they have done. So nice trick. Inside the IC. Inside the IC. They put these gates. They have the gates. All the gates. But nothing is connected. Nothing is connected. You have pins. See, understand? When you buy the IC from the market, you buy the IC from the market. Internally, you have all the gates, everything, but nothing is connected. How do I connect? That's a trick. What this IC manufacturer did was, within the IC, he put a unit called configurable unit or configure unit. This is a small unit. You may call CU. This guy, you can connect with your computer, laptop or PC or whatever it is. And here they're given a software. Then do that here, anything. From there, you download here. This guy will make the connections. There are, you know that the school days that y is equal to a bar b plus b bar a. Y1 is equal to ab bar plus ab, whatever it is. You just write. These are called generally Boolean equations. And there is a software called in our microprocessor, we have called assembly language like that. This is. So they call, that's why they call this PAL ASM. They convert this into the binary file, which connections can be done. And that will be transferred to this configurable. He will make the connections. You can write the equation. Then the software will understand the equation and create a file called bit file. Like your compiler, you write a C code, the compiler converted to binary file. And here they do that. This is actually called, configurable ICs. Understand what is that? Configurable ICs. What is the advantage here? When you buy a component, connections will not be there. You can give the connections to the things. So actually they've called, even though they call configuration, they've given a wrong name called PLD. That's called programmable logic device. That means that I can make the connections myself. That's why they call programmable. That's a mistake they given. They're supposed to call configurable logic device, but they've given it by wrong name. So it's not programmable. It's actually configurable. Both are different words. Configurable function is different. Configuration is different. Programming is different. Please understand. Configuration is one-time offer. Programming is the running offer, sequential offer. In PLD, there are two types, SPLD and CPLD. In SPLD, there are so many types, PAL, PROM, PLA, everything. NCP then came for FPGA. Okay, please understand nowadays we have about millions and millions of gates available internally. You can connect them as you wish. Then people thought, hey, if I have about 10 lakh or 20 lakh gates, 100 million gates, I cannot write the equation. So they have come out with a new language called HDL, Hardware Descriptive Language. That's why you call very long, or VHDL. Also, when they start putting the ICs, when they put 10 transistors per IC, they call SSI, small scale integration. When they put 100 transistors per IC, they call MSI. When they put 1000 transistors per IC, they call LSI. They put more than 10,000 transistors per IC, they call VLSI. Then they stopped, because by the time the competitions are gone and these are gone, nowadays we are putting minimum 10,000 ICs. Okay, that means that what we do here is, you draw a circuit, we have a lens, then we make it small and put it inside the silicon. You understand? That's why we do that. So please understand what we do internally to the IC. This lens makes things smaller and smaller. Because of that, your silicon becomes smaller. Now, latest, one thing, latest ICs, people are having now minimum 10 billion transistors per IC. For example, you have about your SD card, it's about how much? 32G. With 32G, SD card is having 10 billion transistor per IC. Of course, now latest one company has released a chip. The chip is having 1.3. How much? See, think of it. How many crores? Oh, 1,30,000 crores transistors inside the chip. It's a company. They have come out of this in the market. So, this technology itself is called IC design. IC design, or we call it as the field as a VLSI. We call this field as a VLSI. So you here also like a C-like language. Okay, there we call compile. Here we call this process as a synthesis. Both are almost same. When the moment you understand about C and embedded, that time you will start understanding this also. Nothing great. So there were two things we discussed. First one was okay. So what's happening here is this technology. So we have two methods we discussed in IC. The first method is this. The first method of IC is quite simple, where we have a fixed circuit. We have a fixed circuit. And the second method, what we discussed was flexible. The second method was flexible circuit. In the flexible circuit, there are two types. One is called configurable circuit. That is what we call configurable ICs. Then third one was a very nice invention. What people did was, The third technology was very nice. That is, we have a component. Within the component, what we did was, it's a beauty. We put so many small blocks like addition, subtraction, multiplication, division, so many blocks, and a small amount of memory. And there is a small unit called control unit. And this is, we call it as a ALU. And this is called memory. Here, all the connections are done by the control unit based on the instruction you are giving. I'll tell you the difference between these two. There are two things are there in flexible. See, let us go from beginning, then you will understand this. So we discussed about electronics. All right. In electronics, we have discussed about two types: analog and digital. And we are discussing about digital. In digital, there are 4 ways of implementation. Breadboard, that is for generally satisfying ourselves. Then dot board for demo, and PCB, then IC. Okay. PCB is for production. IC is for integration. And there are 2 types of implementation, 2 more types. One is called discrete or IC. Okay. The problem with the discrete is when you have a components become more, my board become big. The drawback with IC is if one transistor goes bad, I have to throw the entire IC. Am I right? So what people did was, when they become more integration started, they have done all these things. They start using only IC. In the IC, there are 3 types. Generally 2 types. One is called fixed. That means you cannot change the connection. The other one is called flexible. In fixed IC, the manufacturer manufactures IC and give it to you. You can only use it. This is called ASIC, application specific IC. This is called application specific IC. Whereas the flexible, you will get the IC from the manufacturer, but you can change the connection as you wish. Understand? So here, the ASIC, the circuit is already done inside. But in the flexible, no connection, nothing. You get the plain IC. You can make components are inside. You can make the connection. How do I do that? I communicate from my laptop. Understand? Now, let us forget about this, because we are not worrying about ASIC. That is, somebody built everything and give it to you. In the flexible, there are 2 types. The flexible, there are 2 types. One type is called configurable. The one type is called programmable. What is the major difference between these two? Is that very, very difference is that in configurable, you have IC. From outside, you download a bit file, or you may call this as a connection file. Connection file. Please understand. This is called connection file. So the moment you upload the connection file, then the connections will be made. The connections will be made, which pin to which pin. But so you apply a 5 volt and you ground. Now connections are made. Once the connections are made, that's it. You can use it. But if you want to change the connection, then you have to stop the process. You cannot use the IC. Then you once again download a new file. So every time when you want to change the connection, you have to download a new file. Once this connection file is loaded, then it's operational. So it is, connections are done one time before start using the thing. In programmable, the program itself is meaning, program is called sequential. So what is happening in programmable, I have a component. Already I have so many blocks. But you can tell me that one number or connection, I will do that. That's why you generally call this a opcode. So this guy makes the connections with the help of a opcode from giving outside. You can give, if you give an opcode 15, he will do one operation. If you do opcode 20, he will do one. Everything is a number. You may call opcode, but that is nothing but a number. So connections are made by giving a number. Same thing like here. But only difference is this is one-time operation, first time. While it is running, you cannot change. But this is not like that. Programming in sequential, when you give the 20, it will make the connections. But if you make 25, he will change the connections. It's so flexible. But indirectly, this is called computer. Because that is nothing but a CPU inside. That is nothing but a CPU inside. Understand? So this microprocessor, this is FPGA. The microprocessor is nothing but CPU inside IC. Please understand, CPU inside IC is called microprocessor. That is IC. So there are 3 types of ICs. One is called ASIC, FPGA, and microprocessor. Only 3. They're done. With that, your electronics field is, that's all, nothing more than that. Now what they have done, they've used this microprocessor plus a ROM to give the data plus a RAM. This forms a small computing unit. Understood? Now, this we'll discuss. It's not our conversation, but we'll discuss at least. We'll make a difference. By next class, I'll give you the difference between these two. This field, when you use ASIC, we call it as a hardware. If you use FPGA, we call it as a VLSI. If you use microprocessor, we call it as a embedded. Now I have a computer inside the system. What happened? I have a computer inside the system, which has CPU, ROM, RAM. You understand now? I have a CPU, I have a ROM, RAM, and I have a electronics. So there is a basic difference. What generally we think is, computers are built using electronics. Am I right? The moment you open a computer, you see all electronic components. But what we don't know is today, electronics is built using computer. Your computer inside electronics is called embedded. So this guy takes care of everything. That's why I repeatedly say that master C programming. Because you have to program this guy. He will take your this is what electronics input is output. This guy will take everything, this guy will give it out. Understand? So here there are two things are there. One is called embedded electronics. Other one is embedded systems. What is the difference between these two? One is embedded electronics, one is embedded system. That has to be understood now. Very, very clear. Okay. That once you understand that, we know how to design a embedded system. So it's a trick here. That is, I have a electronics. Which has an input, which has an output. Now we put a small computer inside. No small. Nowadays we are putting a big computer, also very powerful computer. The computer will take an input and send it out. The moment I say computer means that it has three components: CPU, ROM, and RAM. This is for storing my program. This is for storing my temporary variables, everything. CPU to process. Understand? So this is what you are embedded. Why they call embedded? It's because nobody knows this. We think it's only electronics, but actually this is controlled by the software. It is controlled by the software, which we don't know. That's the reason people generally think embedded is also part of a hardware, but embedded is not 99%, 100% software. There is nothing called embedded hardware, please. All of them only embedded software, please. Embedded means software. We have a lot of confusion, a lot of things in the market. I wanted to have people say that I want to go to embedded hardware. There's nothing called embedded, it's all hardware only. There are three fields: hardware, VLSI, and embedded. You decide which field you want to go. That's the only thing. The here means you should know about digital electronics, all the connections, electrical, everything, timing, and all these things. No softwares. In VLSI, more in digital electronics and more in Verilog and VHDL. In embedded, C or mostly C, little bit of C++ if you want to write an application. This is what about embedded, please. That's why the next session I'll give you more. We'll say that how do we design a product using the embedded. Then you will know that how quickly and easily you can do that. Okay. And later we will discuss, maybe next class, we'll discuss when you will use embedded, when you will use hardware or ASIC. when you will use FPGA and when you will use embedded. That is, we'll come in the coming embedded session. We'll have a thorough idea of when you will use embedded. Okay. So it is nothing but computer inside electronics is called embedded, nothing more than that. So if you the more you are good at computer programming, that's why I always say that there is no difference between normal C programming and embedded C. There's both are same. Both are same. There's no difference. There's nothing called embedded C or anything. There's only one C programming. Okay. So you can ask me if you have any doubt on this. So we'll take a break for about 5 minutes, then we'll come back.